have completed in the last lecture NID, BID, first valid, last valid, total valid IP address and total NID in class A, B and C. Today topic is design and implementation of network scenario before IP saving techniques. Design and implementation of network scenario before IP saving techniques. Or before mid of 1985. Mid of 1985. We have two routers, R1 and R2. These two routers are connected via serial link, and that is the serial port. In the lab we will discuss what is the serial port, what is the Ethernet and fast Ethernet, what is the console port. Port number can be anything, 0, 1 or 2, no problem. Serial 1 or S1. Two routers are connected via serial port, and this symbol represent the WAN connectivity, wide area network. If we are connecting two devices inside the house or directly connected, we are forming the LAN. It's showing the symbol, power symbol is showing the WAN connection. This perpendicular line represent the LAN segment, and we have multiple devices, multiple end users machine connected with the R1 router. Similarly, we have lots of machine connected in the LAN of R2. Let's say the port of R1 is Ethernet. Ethernet means 100 Mbps port. Sorry, 10 Mbps port. Ethernet is a 10 Mbps, 10 megabit per second. And if R2 have the fast Ethernet port, fast Ethernet means a port supporting the 100 Mbps. And the serial link can be T1 link. T1 means 1.544 Mbps, and E1 means 2.048 Mbps, generally known as 1 Mbps link and 2 Mbps link. Our aim is to provide connectivity between R1 LAN and R2 LAN. That is our basic objective. We want to communicate, we want to exchange the information between R1 LAN to R2 LAN. But we are discussing in this area, in this era, 1985, before mid of 1985. If we don't have any IP saving technique, We don't have any IP saving techniques from 1983 to 1985. We have faced a lot of problem in this phase because we don't have any technique so that we can get the desired or required IP address. Let's say we have 1 to 49 machine in R1 LAN and we have 1 to 24 machine in R2 LAN. If we want to communicate between 49 machines, 3 parameter is required. IP address must be unique, belongs to same NID and have unique MAC address. 3 component is required if we want to communicate 2 machines. Let's say we have 2 machines, machine A and machine B. We want to exchange information between 2 machines. We need 3 things. 1, IP address must be unique. Both machines require the IP address but unique. 192.168.100.1 and let's say 192.168.100.2. The first component required is IP address must be unique. Second parameter, network ID must be same. Network ID must be same. And the third component is required, MAC address must be unique. As we know that MAC address is by default unique because it's hard coded into the LAN card. If we are applying the IP address, it can be possible we can apply the wrong IP address and ID can be changed. We require 3 components to communicate between 2 devices if they are directly connected or they can not be directly connected. They are connected via switch between them because today we are not using the hub or bridge. If we have connected 2 devices directly, we require 3 components. IP address must be unique. If 2 machines have the same IP address, we will get one message on the console of the window. IP address is conflicting. Pop-up window is exist. IP address unique. We have the unique IP address. NID must be same. We have the same NID 192.168.100.0. Both IPs coming under this NID. And the third component, MAC address, is unique. MAC address is by default unique. Each machine have the different MAC address. For example, for understanding, we can put the value of MAC address for machine A is A and for machine B is B. If we change any parameter from this, device will not communicate. If we are keeping the same IP address, we get message IP address conflict. If we are keeping the IP address unique, but like this one, 2.2.2.2. One machine IP is 192.168.100.1. Another machine IP is 2.2.2.2. First point is 100% okay, verifying the point number 1. But in case of point 2, number 2 is invalid because the NID of 192.168.100.1 is 192.168.100.0 and the NID of 2.2.2.a is 2.0.0.0. That's why both the machine will not communicate. If we have connect two machine directly, we require the three component. But when we study the switch, hello, yes. जी एक मिनट होल्ड करिए, फोन बाहर दे देंगे, CCNA का इंक्वायरी है. If we want to connect A and B machine not directly via switch, then we required one more component, broadcast domain. Broadcast domain must be same in case of switch, must be same. We will not discuss today, we will discuss in the switch chapter what is broadcast domain. If we are connecting two devices via switch, broadcast domain must be same. It's a fourth component if two devices are connected via switch. If devices are connected directly, only three components it is required to exchange the information between A and B. Okay. If you want to connect two machines directly, we need IP address must be unique, NID must be unique, MAC address must be unique. We have all discussed on these topics. What is broadcast domain we will discuss in the switch chapter, not right now.